Right, shall we start? I hope you're there. Right, let us begin. I thought we will focus on physical today, physical part today. So, kinetics, equilibrium, and acid base. These are the three things that I thought I'll focus on. Uh, where shall we start today? What do you prefer? Like, what do you prefer? To start with kinetics, equilibrium, or acid base? Tell me, tell me very quickly so that we can start somewhere. 30 minutes, 30 minutes, 30 minutes. Right. Okay. What is the first answer? First answer, they say equilibrium. Right. Okay. So let us start with equilibrium then. Right. Yes. Equilibrium, I think. So this is equilibrium, right? Equilibrium. So equilibrium, I will work for 30 minutes. So we were stuck at question number 41. So we'll start from there, right? Question number 41. So let's start with that. Zero point zero 0.06 ammonium bisulfite is present inside a container volume 2.4, 20 Celsius. Calculate the percentage of ammonium bisulfite dissociated when the equilibrium is reached at this temperature. Right. So let us say ammonium bisulfite, NH4HS, right? Solid. It reaches equilibrium to give you ammonia, NH3 gas, and then hydrogen sulfide gas. Hydrogen sulfide gas. Okay, right. So let us say this is the pressure is now ammonia and hydrogen sulfide, the number of moles are the same. So if this is x moles, this is also x moles. So I'll say partial pressure is P, the partial pressure is P, right? Both partial pressures are the same. So Kp is equal to, what is that, partial pressure of ammonia times the partial pressure of hydrogen sulfide. Partial pressure of hydrogen sulfide, both are in the gas phase, right? So what is that? It says partial pressure Kp is equal to 0.05 atm squared. Atm squared. This is equal to P times P squared. So what is the pressure? What is the partial pressure? Partial pressure is equal to square root 0.05. You know, 0.223. 0.223 atm. If you know the partial pressure, you know the number of moles of ammonia formed. So let us look at N, number of moles of ammonia formed. N is equal to, what is that? PV divided by RT. Pressure is 0.223 times 10 to the power 5 pascals. What is the volume? Volume is 2.4 liters, 10 to the power minus 3 cubic meters. R is equal to 8.314 joules per moles per Kelvin. What is the temperature? Temperature is 20. 20 means 293 Kelvin. You get the number of moles. Let us look at that. 0.223 10 to the power 5 times 2.4 10 to the power minus 3 divided by 8.314 multiplied by 293. I got 0.0219. 0.219 moles. So number of moles of ammonia formed is this. So ammonia, that is the amount dissociated. Number of moles of ammonia formed is the amount dissociated. Is it clear? Everybody understood that. So now let us say what is the percentage. What is the percentage of ammonia formed? Percentage of ammonia formed. What is the percentage of ammonia formed? 0.0219, 0.0219 out of 0.06 multiplied by 100%. 0.0219 divided by 0.06 multiplied by 100%. I get 36.5 kilo. 36.5%. Like, I might get 37.17 if I use, make a here 1.013 10 to the power 5. If I use, I can get a kind of a close answer than that. Huh? Did you understand that? Children, all of you, everybody? Ah, check whether you understood that. Right, okay. Now the next one is how many extra moles of ammonia should be added to reduce the percentage of dissociation of the above equilibrium to 10%. Right. So let us say you are dissociating it to 10%. So what is that? Ammonium bisulfide. Ammonium bisulfide solid. At equilibrium, it gives you ammonia gas and a hydrogen sulfide. So let us say X moles of ammonia was added. X moles of ammonia was added. The, the dissociation has gone down to 10%. Again, 10% again, how much is that? Point, you started with how many moles? 0.06. Again, 0.006 moles. 0.06 here. It has gone to 0.006. Here also you get 0.006. Here also you get 0.006. So that is the equilibrium. Now this amount. I think the easiest way to do is not with the number of moles. Easiest way to do it is with the pressure that you work. Right? Method 0.006. Let us look at the partial pressure. Partial pressure is equal to nRT divided by V. What is that? 0.006 times 8.314 times temperature is 293. Volume is the volume 2.4 10 to the power minus 3. This is pascals. We can work with ATM because ATM it is given in kp. Yeah. Okay, 0.006 multiplied by 8.314 multiplied by 293 divide by 2.4 10 to the power minus 3. Got a 6,090 pascals. Got a divide by 10 to the power 1, 10 to the power 5 gives you 0.060. What method then? 0.0609 ATM. So if I now take this entire thing, and then I'll paste it here. Right? 0.0609. What is this? This is this pressure is 0.0609. 0.0600609. I'll take it as 1. 61. Right? Right? 61. So we'll take it 61. 8 here. So what this is P. The X number of moles of ammonia gives you P naught. And this is also 0.006. 0.061 ATM. This is the pressure. These two, when you multiply, you should get Kp. Kp is equal to, what is that? Partial pressure of ammonia multiplied by partial pressure of hydrogen sulfide. Right? Partial pressure of ammonia, P naught plus 0.061. Multiplied by, this is also 0.061. ATM squared is equal to 0.05 ATM squared. Got a P naught plus 0.061 is equal to, what is that? 0.05 divided by 0.061 is equal to 0.8819. 0.8196 kilonewton. What is P naught? P naught is equal to 0.8196 minus 0.061. 0.7586. 0.76 kilomole. 80. But I'll double check that answer, right? Otherwise, you also might not say anything. 0.05 divide by 0.061. 0.8196 minus 0.061 is equal to 0.758. I'll take it as 0.7688. So that ammonia that you add should build up a pressure of 0.76. So what is the number of moles? Number of moles of ammonia that should be added. PV divided by RT. PV divided by RT. Pressure is 0.76, 10 to the power 5. What is the number of volume? Volume is 2.4 liters. 2.4 10 to the power minus 3. R is 8.314. Temperature 293 is equal to moles. Huh? Right. So what is that? 0.76 10 to the power 5 times 2.4 10 to the power minus 3. That is divided by 8.314 multiplied by 293. So I get 0.075. 0.075 moles should be added. The number of moles of ammonia that should be added. Is it clear? Are there any parts that you didn't understand? Anyone want me to explain it again? Right? Anybody want me to explain this? Anything? If you're okay with that, we can go to the next question. Yeah. Everybody? Next question. Everybody understood that? So, like you can work with the number of moles, but it becomes very, very difficult. Like it becomes very lengthy. Right? So if it is Kp, always try to work with the pressures. Then it is easy. Right? Rather than counting the number of moles. Everybody okay with that? Clear then? All of you understood that? You all can chat with me. No question. Yeah. Yeah. Okay. Everybody all right? All right. So right. Okay. If you're okay with that, then let us go to question number 42. Question number 42. See whether we can do this. Question number 42. Ammonium chloride, ammonia and HCl. One is a solid, other two are gases. So ammonium chloride is a solid and ammonia and HCl are gases. Ammonia and HCl. They are gases. Equilibrium pressure of the solid ammonium chloride for a given dissociation is 0.05 atm at 520 K. Calculate the Kp for the reaction. So the total pressure is 0.05. Like, if you have this as a container, so ammonium chloride solid there, ammonia and HCl, total pressure is 0.05 atm. That's what it gives you. So if it is that, let us say if this is partial, if total pressure is P, this is the number of moles is X. Here, this is X. Total number of moles is 2X. So molar fraction is half. 2X. Molar fraction is half. So what is the partial pressure? P divided by 2. Partial pressure P divided by 2. So what is Kp? Kp is equal to partial pressure of ammonia multiplied by partial pressure of HCl. This is gas and this is also a gas. Partial pressure of ammonia is P divided by 2. This is also P divided by 2. That means P squared divided by 4. What is that? 0.05 squared. 0.05, the point, yeah, 0.5 atm squared divided by 4. Atm squared. What is the answer? 0.05 squared divided by 4. That gives you 6.25 10 to the power minus 4. 6.25 10 to the power minus 4 atm squared. Harida, is it clear, everybody? All of you got it? But Harida, check whether you got that answer there. Did you understand how you get how do you get this thing? Right? Right, okay. Right? What is the next thing that they say is this. 0.02 moles of solid ammonium chloride, 0.02 moles of ammonia was allowed to reach equilibrium in a container with a volume this much. Calculate the partial pressure of HCl and ammonia inside the container. Right. So you have ammonium chloride solid at equilibrium gives you ammonia gas and HCl gas. So to begin with, you have 0.02 moles. Ammonia also 0.02 moles. HCl nothing, right? Partial pressure ammonia inside the container. So with you have 0.02 moles, let us get the pressure that is there. I told you we can work with the pressure, it is easy, right? What is the pressure? Pressure is equal to nRT divided by V. PV is equal to nRT. Number of moles is 0.02 at the moment, right? R is equal to 8.314. Temperature 520 divided by volume. What is the volume? 50, no, sorry, 40, 42.7. 42.7 10 to the power minus 3. This is Pascals, huh? So what is that? 0.02 times 8.314 times 520 divided by 42.7 10 to the power minus 3 is equal to 2024.9. Another 2024.9 Pascals. So since it is given in ATM, let's work with ATM. Divide by 110 to the power 5. So 0.020 ఇలా ఉంది. 0.020. 0.02 ATM. ATM is that. But now if I take this ammonium chloride solid at equilibrium giving you ammonia gas and HCl gas. Ammonia pressure is 0.02 to atm. ATM. Now it should react in the forward direction because there's no HCl. It should react in the forward direction. So when the forward direction reaction take place, some amount of HCl is going to form. So that will increase the pressure to by P naught. Ammonia also same amount will form. That will also increase by pressure by P naught. So what is the total pressure now? 0.02 plus P naught. This is also P naught. Now what should happen? It should become equilibrium. That means it should be equal to Kp. Kp is equal to partial pressure of ammonia gas times partial pressure of HCl. Kp value they have given 0.05 atm is equal to 0.02 plus P naught times P naught. Right? Now you have a quadratic equation. You solve the quadratic equation. P naught squared plus 0.02 P naught minus 0.05 atm is equal to 0. So you have to understand that you get the pressure in atm. So P naught is equal to, what is that? Minus B, 0.02, plus or minus B squared, 0.02 squared, minus 4AC, 4 times 0.05, divide by 2. Then 0.02 squared plus 4 times 0.05, square root of this, minus 0.02 divide by 2. Sorry, no, 0.214 කියලා no, 0.214. මොනවාද? ATM. Right. අප double check කරමු, right? 0.02 squared plus 4 times 0.05. Right, okay. And then square root of this minus 0.02 divide by 2. So 0.213 kilo, right? 0.213. 0.213, and then what are the pressures? Partial pressure of ammonia 0.02, 0.02 plus 0.214 atm. Partial pressure of HCl, what is that? Normal value 0.214 atm. But the values here are little wrong. I don't know, 0.05. This is right. What is the value? Kp value is 0.05 atm. Pressure is 0.02. 0.02 P naught. They put the P naught plus 0.02 minus, this is okay. I'm just double checking these ones. 0.02. Yeah. Anyone else? Isn't it 6.25 atm? එහෙම තියෙන්නේ 6.25. Did I 6 point, yes, Kp, no? Kp, not 0.05. That is wrong. I have taken the wrong pressure. Right? Yeah, you are right. This pressure, this is Kp. Kp is 6.25 10 to the power minus 4. Right? Okay, this is 6.25 10 to the power minus 4. I have used the wrong value. What do I check? Let's do that. 6.25 10 to the power minus 4. 6.25 10 to the power minus 4 here. Right. Let us double check that. 0.02 squared plus 4 times 6.25 10 to the power minus 4. Square root of this minus 0.02 divide by 2. 0.0169. So that is P naught. If the P naught is that, P naught is 0.0169. So go to 0.0369. Then no 0.0169. Now it's okay, I think. The answers. May I have used the wrong value here. Pressure, right? Not Kp. 2A tamai, yes, 2A, but the A is 1 here. It's over 2 divided by 2. There is no problem. Ratan, I have used the wrong value for the KP. Yeah. Right. Is it clear? Question number 42. Did you understand that? Everyone? Question number 43. Question number 43. Consider the following equilibrium. Nitrogen, hydrogen, ammonia. Nitrogen, hydrogen are mixed in 1 to 3 molar ratio and studied at 10 atm. Constant 10 atm pressure. Right? Nitrogen, hydrogen at equilibrium 2 ammonia. How many win? So total pressure is 10 atm. You maintain at 10 atm. Right. Detail of the study are given below. 350 degrees, partial pressure of ammonia is 0.75. So this is the partial pressure of ammonia, 0.75 atm. Can you tell me what is the nitrogen and hydrogen pressure then? This is the ammonia, 0.75 is the partial pressure of ammonia. What is the pressure of nitrogen and hydrogen? 10 minus 0.75. Again, 9.25. 9.25 atm. Since you use 1 to 3 ratio, that 9.25 is exactly divided in 1 to 3 ratio. So this should be 9.25 divided by 4 multiplied by 1. This should be 9.25 divided by 4 multiplied by 380. Make a 0.7580. Did you understand that? What is that? 9.25. 9.25 divided by 4 is equal to 2.3125. 9.25 multiplied by 3 divided by 4. That is 6.9375. 6.9375. Here it is just 0.7580. Calculate the equilibrium partial pressure of hydrogen and nitrogen at both temperatures. So this is at what temperature? 350 degrees. Right? You got 450 degrees. 450 degrees, if you look at it, here the partial pressure is 0.2 atm. That means 10 minus 0.2 is equal to 9.8 atm. This one is total 9.8. 9.8 atm. So nitrogen is 9.8 divided by 4. Then I know 9.8 multiplied by 3 divided by 4. So their pressures are 9.8 divided by 4, 2.45. This one is 7.35. Then a 0.2 atm. Right? This is the other one. Okay. Calculate the Kp for the reaction at both temperatures. At 350 degrees Celsius, what is the Kp? Kp is equal to partial pressure of ammonia squared, NH3 squared. Yes. Divided by what? Partial pressure of nitrogen. Partial pressure of nitrogen squared times partial pressure of hydrogen to the power 3. Let us substitute these values. 0.75 squared. Nitrogen 2.3125. Hydrogen 6.9375. to the power 3. So it's your top unit is ATM to the power minus 2. So what would you get? What would you get? 0.75 squared divided by 2.3125. That is divided by 6.9375 to the power 3. 0.75 squared. 0.75 squared divided by 2.3125. That is divided by 6.9375 to the power 3. 7.285, 7.285, 10 to the power minus 4 ATM 2 minus. If you have done it, then can you please confirm it? What is that? What is your answer? The other one is 450 degrees. That also I will do. KP, right? You should get a different answer. Partial pressure of ammonia squared. This is partial pressure of nitrogen gas times partial pressure of hydrogen to the power 3. Value is 0.2 squared divided by partial pressure of nitrogen 2.45. What is the other one? 7.35 to the power 3. 0.2 squared divided by 2.45 divided by 7.35 to the power 3. 4.11 10 to the power minus 5. 4.11 10 to the power minus 5 ATM to the power minus 2. See whether you all get those answers. Right? State whether the reaction is exothermic or endothermic. Exothermic or endothermic. You can see when you increase the temperature, this has favored in the backward direction. You can see this is 2.31. This is 2.45. The products have gone down 0.75 to 0.2. That means it has favored in the backward direction. So at high temperature, backward reaction is favored. That means reverse reaction absorbs energy, right? So nitrogen plus hydrogen, the temperature or the energy is on this side. Energy is on this side. So when you increase the temperature, you can see that it favors in the backward direction. If the energy is in the product side, that means it is exothermic. So therefore, this is a exothermic reaction. Thermic reaction. Equilibrium partial pressure of ammonia at 350 and 50 atm is 12. Calculate the Kp of this reaction under these conditions. Now, usually theoretically, what should happen is like the Kp cannot change at 350. You should get the same answer, but I'm not sure whether you get the same answer because depends on the values that are there. Like nitrogen gas plus hydrogen gives you ammonia. Partial pressure of ammonia is 12 atm. Okay, 12 atm. So total pressure is 48. 12 atm. 50 can 48. 38. 50 minus 12. 38. Out of 38, this will give you divided by 4. This will give you 38 divided by 4 multiplied by 3. atm. So these are the values that you should get. 38 divided by 4, 9.580. Make that. Multiplied by 3, 28.580. This is 1280. So what is the Kp value? Kp value is partial pressure of ammonia squared, divided by partial pressure of nitrogen, partial pressure of hydrogen. What is the values? What are the values? You get 12 atm squared. What else? Nitrogen, 9.5 atm. 28.5 atm to the power 3. So that's the value that you should get now. 12 to the power 2 divide by 9.5 divide by 28.5 to the power 3. You get 6.54 10 to the power minus 4. Everybody got it? Hurry. Explain the effect of catalyst on the following situations. Rate of reactions increases. Equilibrium state is not changed by adding a catalyst. No change in the equilibrium. Right? We have passed 30 minutes. Right? Question number 44. Right. 50 milliliters of acetic acid with a density, this one, 50 milliliters of ethanol with a density this much was allowed to mix with the equilibrium. If the Kc is 4 at this temperature, calculate the number of moles of water molecules produced at the equilibrium state. So let us look at the number of moles of acetic acid. CH3COOH. Mass is equal to density times volume divided by the molecular mass. Mass is density times volume divided by the molecular mass. Density is 1.05. Volume is 50. Molecular mass is 60. Acetic acid molecular mass is 60. So that will give you moles. What is that? 1.05 times 5 divided by 6 is equal to 0.875. So number of moles of ethanol. Number of moles of ethanol also you can do it in the same way. DVOM. DV. 0.8. Volume 50. Ethanol molecular mass is 46 then. 24 plus 6 plus 16. 46. Yeah. What is that? 0.8 times 50 divided by 46 is equal to 0.869. 0.87 kilogram. Like that part I have rounded off. So you have acetic acid, CH3COOH, plus ethanol, C2H5OH. You remember how the ester is formed? Ester, you get CH3, COO, C2H5 plus water. This is liquid. This is liquid. This is liquid. This is liquid. Right. So how does it work? 0.875. 875. Make it 0.87, something like that. May like X has reacted, X has reacted. This is X, this is X. Mama, I will round it off and do the calculation. 0.875. I will take it as 0.877. 87. Make though the calculation is easy, but you might not get the most accurate answer. We'll see. 0.87 minus X. This is also 0.87 minus X. This is X and this is X. Volume is the same. So Kc is equal to ester, water, divide by acid and alcohol. So that gives you x squared divided by 0.87 minus x squared is equal to 4. Because it is given as 4, that's why I took it as 0.875, took it as 0.87. Nah? So x divided by 0.87 minus x is equal to 2. So x is equal to 0.87 multiplied by 2 minus 2x. We get another 3x is equal to 0.87 multiplied by 2. X is equal to, what is that? 0.87 multiplied by 2 divided by 3. 0.58 kilo. 0.58 moles. So what is the number of moles of water formed? Water formed is X, 0.58 moles. නේද? හරි. ඒක එහෙනම් ওই ටික ඉතිරි ටික will keep it for another day, right? පොඩ්ඩක් කරන්න. මේ ටික කරලා like try to do it if there are kind of urgent questions to look at මට ටක් ගාලා තව එකක් බලන්න පුළුවන් if you really want, but otherwise we'll go for either acid base or kinetics, right? මොකද ඔයාලා කියන්නේ? What do you want? Kinetics or acid base? If you tell me, we can quickly move on to this. That's equilibrium questions. Now I have left with kinetics and acid base. What do you prefer? Ken, neither. Already sleepy? Right? Okay, kinetics. Right. Let us look at kinetics then. So kinetics, I think we were left behind, got stuck at question number 50. We finished 50. Acid base IO. Let's do kinetics කියලා කිව්වා ගොඩක් අය. කීප දෙනෙක්. We'll do acid base after that. I think we are at 51 tutorial. Same question, tutorial number 51. Question number 51. හරි. Rate of reaction increases significantly when the temperature is increased by a small amount. Use the Boltzmann distribution plot to explain this statement. I think in this tutorial, I have given that question many places. We have explained it many times using this method. And you say the Boltzmann distribution curve changes, and at the very low temperature, you have only a fraction of molecules. At a higher temperature, you have a large number of molecules having the necessary energy so that can have a successful collision. You need to write it down. Right. Assume that the compound A given below is soluble in water. CH3, O, S double bond oxygen, O, CH3. Dimethyl sulfate. 1 mole of this compound undergoes hydrolysis slowly with water to form 2 moles of ROH. ROH කියලා කියන්නේ මෙතනින් නේ, right? So it attacks water from water. Then we have, like since I have given you these mechanisms, ඔයාලට දැන් මේවා you should be able to think about it. මේක ටොක් ගාලා attack කරනවා. This is going to break over here, right? And in the next step, it comes back over here and this is going to leave, right? In another step, this is going to leave, and that is how you get this ROH, CH3OH, 2 of them, right? What is the resulting, what is the other product? This sulfur with that oxygen, you get sulfuric acid, H2SO4. CH3OH and sulfuric acid is what you get. Another product, assuming that both moles of ROH are formed at the same time. This is formed. How would you attempt to determine the order of the reaction? Explain briefly. So what is the method that you suggested? What are the methods that you all suggested? Right? You can add sulfuric. How can you detect sulfuric? Right? You can add barium chloride. If you add a quantity of barium chloride, it will react with the formed sulfuric and it forms barium sulfate precipitate. And you can use a cross. And then cross you keep on watching this cross, observing this cross like the thiosulfate reaction. And the time taken for the turbidity to happen, you can monitor. That's how you measure the rate. Explain briefly. So you change the concentration of this and time taken to measure the time taken to disappear the cross, you measure. Based on that, you can look at the rate of the reaction. Fine? That's okay, na? You can briefly explain it? Mama, it was a question number 52. If there are questions, you should ask. Right. Question number 52. N2O5 decomposes according to the equation. Reverse reaction is neglected at 400 Kelvin. The order of the above reaction with respect to N2O5 was determined by placing a mixture of N2O5 and an inert gas in an evacuated bulb of volume 8.314. So there's a bulb of volume 8.314 cubic decimeters maintained at 400 Kelvin. Measuring the pressure of the gas as a function of time. Using the data given in the following table, calculate the amount of N2O5 reacted after 5 seconds of each of the experiment A and B below. Alright. So 2N2O5 gas. I'm giving you 4NO2 gas plus oxygen. Right. So at the very beginning, N2O5 you had a 0.125. Let us say 2x moles reacted after 5 seconds. Then this will be 4x, this will be x. 0.125 minus 2x. 4x. At the equilibrium. But then don't forget that there is an inert gas also. I don't know what that is. 0.125 moles are there. So what they ask is the amount of N2O5 reacted after 5 seconds. So PV is equal to nRT. Pressure 1.012 10 to the power 5 pascals. Volume 8.314. 8.314 10 to the power minus 3 cubic meters. Number of moles. Here then point. Now I'm just adding them. What I'm doing is I'm trying to add all these. These are all gases. 0.125, 2x, 4x, x, 5x minus 0.125, 0.125 plus 3x plus another 0.125. Why? Because your helium is also there. Now don't forget that. 8.314 joules per moles per Kelvin. Moles. What is the temperature? Temperature is 400 Kelvin. 400 Kelvin. Right. Okay. So let us simplify this. 8.314, 8.314 cancels out. 10 to the power minus 3, 10 to the power 5 is 10 to the power 2. 10 to the power 2 is this is that. 0.25 plus 3x. I add them together. 0.35, 0.25 plus 3x is equal to 1.012 divided by 4. 0.253. 3x is equal to 0.003. X is equal to 0.001. That is the amount reacted. What do they ask? They ask you to calculate the amount reacted. We have taken the amount reacted as 2x. So in experiment A, Amount reacted would be 0.002 moles have reacted. Did you get that? දැන් කවුරු හරි කෙනෙක් කියන්න බලන්න මට නිකන් whether you have done it, attempted it. නේද? See. Right? Have you done it? Did you attempt it? What is your answer? Everybody all right with that 0.002? This is the number of moles of N2O5 reacted. 0.002 is the number of moles that is reacted. Right. Let us do the part B also. We'll do experiment B, part B. Experiment B. Like in that you have the kind of very similar reaction, similar kind of thing, right? So maybe we will cut and paste. I'll cut this out. And then we should be able to do this. Maybe we'll paste it here and get it done. So what's happening there? You have 0.25 moles. Let us say 2y has reacted. This is 4y. This is y. Number of inert gas is also 0.125. PV is equal to nRT. Pressure 1.524 10 to the power 5 pascals. Volume is 8.314. 8.314 10 to the power minus 3 cubic meters. nRT 8.314 joules per moles per Kelvin. RT is 400 Kelvin. What is N? N is equal to 0.375 plus 3y. Did you get that? 0.375 plus 3y. 0.375 I got it from this. 0.25, 0.125, 0.375. Right? So let us see whether we will simplify. 1.524 divided by 4. 0.375 plus 3y is equal to 0.381. 3y is equal to 0.381 minus 0.375. 6 10 to the power minus 3. It is divisible. So y is equal to 2 10 to the power minus 3. Amount reacted is 4 10 to the power minus 3. Reacted 4 10 to the power minus 3 moles. So amount of N2O5 reacted after 5 seconds in each of the experiments A and B below. The order of the reaction with respect to N2O5, if the time taken for the reactant to reach 400 Kelvin negligible. Right. So what is the rate? Total pressure. Total pressure. Right. Okay. So rate is equal to what is that? K times N2O5 gas to the power simple x. X is the order with respect to N2. K is the rate constant. You have to write it down. All right. Right. Total pressure. Rate is proportional K dash to the change in the pressure over time. Change in the pressure over time. So you can say change in the pressure over time is equal to K times change in the pressure. I mean, they have given the pressure, sorry. Get that. Rate is equal to number of moles of N2O5 reacted divided by time. Proportional, K dash. Number of moles. So number of moles of N2O5 reacted in the first case is 0.002. So 0.002 moles divided by volume multiplied by 5 seconds. Rate moles volume. Volume is 8.314. I didn't substitute it because it is a constant. K times N2O5 concentration. පළවෙනිට දීලා තියෙනවා 0.125 divided by V. Simple X. Equation 1. Equation 2 again, next one. How much has reacted? 4 10 to the power minus 3. 0.004 moles, the second one. Divided by volume times 5 seconds is equal to K times, what is the number of moles? 0.25. 0.25 divided by X name. So you can now solve this. 2 divided by 1. Everything cancels out. 0.004 divided by 0.002 is equal to 0.25 divided by 0.125 to the power x. Okay, 2. This is also 2. 2 to the power x is equal to 2. Therefore, order with respect to this is equal to 1. Explain in molecular terms the effect of increase of the pressure of N2O5 at constant temperature on the rate of the above reaction. When you increase the pressure, what will happen? Increase the pressure, number of collisions increases. Number of collisions in the desired orientation also increases. So therefore, rate of reaction increases. All right, we can check whether you understood this part. Yeah. Like you have PV and RT question. Now, like rate take a put there is only very small part of the rate here. Only this part, the rate. Other than that, you have PV and RT kind of thing. Is it clear? Right. Then question number 53. Question number 53. Right. Chlorine dioxide undergoes the following reaction under basic medium. pH of the solutions are given below in the table. Right. pH 12 means what is the hydroxyl concentration? Hydroxyl concentration, POH is 10 to the power, POH is 2, 10 to the power 0.01 molar. pH 12 is that, pH 13 means hydroxyl concentration is equal to 0.1. moles per cubic decimeter. Right? Determine the orders with respect to ClO2 and OH minus. I think rate is equal to K times, what is that? ClO2 aqueous to the power simple A, hydroxyl to the power simple B. I think you substitute 0.0220 moles per cubic decimeter per second is equal to K times 0.06 moles per cubic decimeter to the power A. 12 කියලා කියන්නේ 0.01 moles per cubic decimeter to the power B. Next one is 0.0025 is equal to K times concentration is 0.02 moles per cubic decimeter to the power A, 12.01 moles per cubic decimeter to the power B. Moles per cubic decimeter per second. Moles per cubic decimeter. Moles per cubic decimeter. And K, 0.024 is equal to K times 0.02 to the power A, zero point 0.1 to the power B. So now what you do is you divide as usual, you divide equation 1, equation 2, equation 3. But when you're writing it for the exam, don't be lazy like me to write the units. Okay, unit එක හරියට දාන්න, right? And here it is little, there's only tiny bit of space also. Right. I'm just giving excuses. What is it? And then no. 1 divided by 2. 0.022 divided by 0.025. 0.0025. 0025 is equal to 3 to the power A. And what is that? 10 meters, the 0.022 divided by 0.0025. 8.8. 3 to the power A is equal to 8.8. That means A is equal to 2. 9. Like, 3 divided by 2. 3 divided by 2. So that will cancel out. 3 divided by 2. No, 2 divided by 3 again. Put a 0.1. 0.01 divided by 0.1. I'll do it in the other way around. 3 divided by 2. 0.1 divided by 0.01 is equal to 0.024 divided by 0.0025. 10. 10 to the power B is equal to, make a 10 roughly around 10. B is equal to 1. Did you all get those answers? Right? Did you understand that? The mechanism of the reaction does not change when the temperature is raised by 10 degrees. If the temperature of the reaction is raised by 10 degrees, what would happen to the following parameters? Would it increase, decrease, or remain same? Rate of the reaction. When you increase the temperature by 10 degrees, normally the rate of reaction increases. Even though the rate of the mechanism doesn't change. So when the rate increases, Order the reaction with respect to each species, no change in the mechanism. If there is no change in the mechanism, order of the reaction doesn't change. Order, no change. Clear? Did you understand that? It's all right. Right, okay. So that is also 30 minutes. 30 minutes, right? I thought I will be able to do other questions also. Right? But anyway, now let us do the acid base. You have to kind of do it better gradually. Yeah. And now acid base, we haven't done much. So we have done only 11 questions last time, I think, as far as I remember. So we'll work on that acid base. Huh? Now, acid base. Question number 12. Right. Let me get some pages here. See whether we can do that. At 298 Kelvin, acid dissociation constant of chloric acid is this much. Find the ionic concentration of hydronium, hydroxyl, HOCl aqueous species. So HOCl aqueous, it undergoes dissociation with water, H2O liquid, and it gives you H3O plus aqueous, and then OCl minus aqueous. Right. So what is this K? K is equal to H3O plus concentration, OCl minus concentration, divided by HOCl concentration. These two are both the same. They are 1-to-1 ratio. So dissociation constant is 3.2 10 to the power minus 5. This is hydronium ion concentration squared. HOCl concentration is 1.25 10 to the power minus 2. Remember the moles per cubic decimeter. This is also moles per cubic decimeter. So hydronium ion concentration, how much is that? Hydronium ion concentration. Hydronium ion concentration is 3.2 10 to the power minus 5 multiplied by 1.25 10 to the power minus 2 and the square root of that. 6.928 10 to the power minus 4. Right. That is the hydronium. Then you can calculate the hydroxyl. Hydronium times hydroxyl, hydroxyl times hydronium concentration is equal to Kw. 1 10 to the power minus 14. So what is the hydroxyl concentration? Hydroxyl concentration is 1 10 to the power minus 14 divided by 6.928 10 to the power minus 4. 1 10 to the power minus 14 divided by 6.928 10 to the power minus 4 is equal to 1.44 10 to the power minus 11. Because this is acidic, the hydroxyl concentration is low. Is it clear? Is that clear? Find the pH value. හරිද? කියන්න. Wake up. Did you all get it? Right? Did you all get it? Okay. You got it, right? Right. You must say, what is the pH? pH is equal to minus log 10 hydronium ion concentration. What is the hydronium ion concentration? Hydronium ion concentration is 6.928 10 to the power minus 4 pH. Then log 6.928 10 to the power minus 4 is equal to 3.159 කියලා තියෙන්නේ. 3.159. Everybody understood that? So that was question number 12. How are you doing with acids, bases? Those kind of questions. Were you able to Do them properly. Still have problems. How is it? Do you manage them? Theoretical cannot hurry now. Right, don't worry. Right. Shall we do question number 13? Question number 13. Work it out. At 25 degrees Celsius, 0.002 moles per cubic decimeter concentrated ethanoic acid has been dissociated by 2.3%. If the dissociation constant is 8.5, find the pH value, right? So, what is the hydronium ion concentration? You don't need the dissociation constant. Hydronium ion concentration is 0.002 multiplied by 2.3 divided by 100. So this is the concentration because the amount dissociated is 3%, 2.3%. So what is that? 0.002 times 2.3 divided by 100 is equal to 4.6 10 to the power minus 5 moles per cubic decimeter. So what is the pH? pH is equal to minus log 10, 4.6 10 to the power minus 5. So log this answer 4.3372. Question number 13. Question number 14. See whether you can do that. At 298 Kelvin, the dissociation constant of methanoic acid is this much. Calculate the pH value of 0.00 HCOOH. 0.05. So HCOOH aqueous plus water gives you HCOO minus plus hydronium ions. Now you can see these two concentrations are the same. They are both the same. So it's controlled by K. K is equal to hydronium ion concentration squared divided by HCOOH. Ka 1.8 10 to the power minus 5. H3O concentration squared. HCOOH concentration is 0.05. So what is the hydronium ion concentration? Hydronium ion concentration is equal to 1.8 10 to the power minus 5 times 0.05. Square root of this. 9.48 10 to the power minus 4. So what is the pH? pH is equal to minus log 10, 9.48, 10 to the power minus 4. Get the log value of this. 3.022 3.02. What is the value given? 3.0198. 1.8 10 to the power minus 5 times 0.05 and the square root of this yeah, log of that 3.022, right? Okay. Right. It was say question number 15. Did you all try that? Question number 15. The solution consists of 1.2 moles per cubic decimeter HCl, zero point 0.1 molar acetic acid. If the dissociation constant is this much, find the pH of the solution. In the presence of a strong acid, weak acid ionization is negligible, right? It doesn't ionize. So everything comes with strong acid. Let's see here. So concentration of H plus 1.2 moles per cubic decimeter. So what is the pH? pH is equal to minus log 10, 1.2. So what is that? Log 1.2 is equal to minus 0.09718. Minus 0.0, not 797, No, no. But you have to mention that in the presence of a strong acid, in the presence of a strong acid, weak acid ionization is negligible. Ionization is negligible. You got the idea? Question number 15 is that. Question number 16. A solution contains 0.02 concentrated nitric acid and 0.01 concentrated ethanoic acid. Calculate the dissociated amount of acetic acid and the pH of the solution. Right? Now, pH of the solution mainly depends on the strong acid. Right? H plus ions depends on the strong acids. Depend on the strong acid. So weak acid ionization is negligible. So what is the pH? pH is equal to minus log 10. Strong acid is 0.02. Right? So what is that? Log 0.02 is equal to 1.6989. 1.6989. pH. That's the pH. Calculate the dissociated amount of acetic acid. So Ka is given by another CH3COO minus H3O plus divide by CH3COOH. Right? Aqueous. K. What is K? 1.8 10 to the power minus 5. K is 1.8 10 to the power minus 5. Now, the amount dissociated, we don't know. So, that is given by CH3COO minus. Hydronium ions are mainly depending on the strong acid. That is equal to 0.02. Amount dissociated is negligible. So, it is roughly equal to the initial concentration, 0.01. So, 0.01, make a 2 This is the acetic acid concentration. So, acetate concentration is equal to here. Divide by 2, you get a 0.9. You get a 9, 10 to the power minus 6 again. So, that is the percent dissociated. Percent dissociated is that. 9, 10 to the power minus 6. Not percent, the amount dissociated is 9, 10 to the power minus 6. Did you all get that value? Those who have done it? Where, like the main theory here, right? I hope you understood it by that this time. The main theory here is the amount dissociated is negligible compared to the strong acid. Is it clear? Amount dissociated is negligible compared to the strong acid. In the presence of a strong acid, amount of H plus given by the weak acid is negligible. Always remember that. Right. So that is question number 16. Question number 17. 17. Right? 1 cubic decimeter solution is made by 0.1 molar HCl and 1 molar acetic acid. Find the ionic concentration of these ones. This is what you have, right? So the hydronium ion concentration is 0.1 because this is strong acid. HCl is a strong acid. So Ka is equal to CH3COO minus hydronium ion concentration, H3O plus concentration, divide by CH3COOH. Ka 17. Ka is 1.8 10 to the power minus 5. CH3COO minus hydronium is 0.1. Acetic acid, the concentration is 1 molar. So you get CH3COO minus 1.8 divided by 0.1. 1.8 10 to the power minus 4. That's all. Put it on 70. But 20 right? 18. At 25 degrees Celsius, find the pH value of the solution in which concentration with respect to ethanoic acid, 0.1, sodium ethanoate is 0.005. This is this. What is that solution? You have ethanoic acid as well as sodium ethanoate. Both are there. That means it's a buffer solution. The salt and the acid both are there. It's a buffer solution. pH is equal to pKa, Henderson equation, plus log 10 salt divided by the acid. Right? So this is minus log 10, 1.8, 10 to the power minus 5. Plus log 10 salt. Salt is how much? Ethanoic acid salt is 0.005. Acid is 0.01. Okay. Log 1.8 10 to the power minus 5, 4.7447. 4.7447 plus 0.005 divided by 0.01 log of this is equal to minus 0.3010. What is the value? 4.7447 minus 0.3010. 4.4437. Question number 80. Question number 19. You must be tired now. Question number 19. At a temperature, the dissociation constant of ethanoic acid is this much. Show that the pH value is 5.7 in 1 cubic decimeter aqueous solution which contains 0.02 ethanoic, 0.2 sodium ethanoic. Ethanoic and ethanoate both mixed together, it's a buffer solution. So pH is equal to again pKa plus log 10 salt divided by acid. 1.8 10 to the power minus 5, 4.44, 4.7447. This is the earlier value that we have used. Right. Plus log 10, salt concentration 0.2, acid concentration 0.02. 1 over 10. What is that? 1 over 10 is 4.7447. 1 over 10 is minus 1. Put in 3.7447. It's not 5 point. But above that, when we show that the pH value is 5.7, which consists of 0.02 molar ethanoic acid. Ethanoic acid 0.02, zero point 0.2 molar sodium ethanoate. It should be the other way around. ඒක පොඩ්ඩක් correct කරගන්න. Show that the pH value is 3.7. Nah? If this is the value. If it is other way around, it will be 5.7. Question number 20. We'll do this as the very last thing today. It was say, right? Okay. When 0.1 molar sodium methanoate is added to 1 cubic decimeter solution of 0.02 methanoic acid, from which amount the pH value increase in this solution? At this temperature, dissociation constant of methanoic acid is 1.8 10 to the power minus 5. Right. Sodium methanoate is added to 1 cubic decimeter. So let us say what is the first one? Methanoic acid. HCOOH. Aqueous. H2O. Liquid. At equilibrium, HCOO minus and H3O plus. Right? So you know Ka is equal to, these two concentrations are the same, hydronium ion concentration squared divided by HCOOH. K is 1.8 10 to the power minus 5. HCOOH concentration is 0.02. But if you take the square root, you get the hydronium ion concentration. So what is that? 0.02 times 1.8 10 to the power minus 5 and the square root of this. The 6 10 to the power minus 4. 6 10 to the power minus 4. Let me double check that. Right. 1.8 10 to the power minus 5 multiplied by 0.02 square root of that 6 10 to the power minus 4. So what is the initial pH of this solution? pH of this solution is log 6 10 to the power minus 4, 3.2218. The පටන් 3.2218. This is an acid. Now to this you add 0.1 molar sodium methanoate. When you add that, it becomes a buffer solution. Because you have the salt and the acid both, pKa plus log 10, salt and the acid. pKa is minus log a 1.8 10 to the power minus 5, 4.7447. This is the value that you have calculated earlier. Log 10 salt. Salt is 0.1. Acid. Acid is 0.02. So now what is the new pH? 0.1 divided by 0.02 and the log of this, right? 4.7447 plus this answer, 5.4436. That is the pH, new pH. So what is the pH, delta pH? 5.4436 minus 3.2218. 5.4436 minus 3.2218. 2.2218 2.2218 is the delta pH. Then, right. Okay, I'm not going to keep you waiting for another period. I think then question number 20 right? Next week we'll do the remaining set of questions. Right? And see whether you can do it on your own. Take care, right? Work hard. Okay? Bye.